All right, so some people in second hour wanted me to go over this question. It's from the page 176 stuff, I believe, and it's number 42. When you look at the instructions, it says use a graph to solve the equation in the interval negative 2 pi to 2 pi. Well, I'm not a huge fan of listening to the book on how to do things, but I can see what it's telling me to do. It's telling me it wants me to solve the equation on this interval. So what does that mean? Well, when we look at the question, cotangent of x equals 1. When it says solve, keep in mind solve is saying find the solutions. It's asking me what can x equal to make that statement true. And then if you think about this, in all of the trig functions, all the periodic functions, a lot of them have infinite solutions at times, because I can just, they're all based on that idea of the circle, and I can just keep going around and around and around and around in the circle. And so that's why it's telling me, negative 2 pi to 2 pi. So it's really telling me 2 pi. So look all the way around once, but also look backward once. So I want to figure out all of the solutions there. All right. So let's go back to the question now that I understand what it's asking me to find. I want to figure out all the angles in the purple, the angles inside that purple kind of region that would make cotangent equal to 1. Well, cotangent of x equals 1. I'm not a huge fan of cotangent. I don't work with that function very much. I would rather see this as tangent, because I know it's connected, So I know that tangent and cotangent are reciprocals of one another, flipped fractions. So if cotangent is 1, that's really like 1 over 1, it means tangent would be 1. Ah, that's nice. So then I can think about where is tangent, what angles make tangent equal to 1. Well, I know an angle that makes this true because I have my trig automatics memorized. You guys have a table, but if you look at that table, you know that at pi over 4, okay, tangent equals 1, so I know that x could equal pi over 4. So that's really one spot, and maybe I should mark them nicely. So that's one spot where tangent would be equal to 1. And I can see it because that triangle, my opposite over my adjacent is the same. So the question is, could I put that triangle somewhere else and still get a value of tangent being equal to 1? And the thing is, I could put it back here, but tangent would be negative 1 there because I have a positive opposite side and a negative adjacent side. So that's not good. Don't want to be there. I could put it down here, and if we look, we'd have a negative opposite side and a negative adjacent side. And so tangent would be positive there. I know tangent's positive in the third quadrant. So what's that angle? I know it's really like pi over 4. It's just past pi, because I have a pi over 4 angle in there. And so it's like I want to go pi over 4 more than pi, so it's like pi plus pi over 4. Or if I know my unit circle really well, I could just say that's 5 pi over 4. And then similarly, I could look at a triangle in the fourth quadrant, but I know tangent's going to be negative there too, so that one's just not going to work. So those are my two spots, and that's if I'm going forward, if I'm rotating in a positive way, but I could still get to those yellow angles if I was rotating in a negative direction. It's just a matter of how would I get there. So I'm really looking for coterminal angles here, or how could I get to this yellow angle in a by rotating in a negative direction. And so I know that that one is really negative Actually, you know, I'll put them right below. Negative 3 pi over 4. Because that's the same as 5 pi over 4. They're 2 pi apart, you know, 1 full rotation apart. And then pi over 4 is really like negative 7 pi over 4. And so when I look at this, I went forward 1 full rotation. Those are my angles here. And I went backward 1 rotation, and those are my angles here. And so these are all the solutions. These are all of the angles that make that statement true. So they're my answers. Hope this helps. Have a great weekend.